Particle moves along the curve x equal to 4 cos t, y equal to 4 sin t, z equal to 6t. We need to find the velocity and acceleration at the time t equal to 0 and t equal to pi by 2. So in the first part we need to get the velocity and also the acceleration. And then in the second part we also need to find the magnitude of velocity and acceleration at any time t. Right? Let's do the first part. It is given that x, y and z in terms of t. These are the parametric equations given to us. So let r vector be the position vector of the particle at any time t. Any time t. Right? Then what is r vector? The position vector is xi vector plus yj vector plus zk vector. Right? Let v be the velocity of the particle, or let velocity of the particle be v vector, right? And acceleration of the particle be a vector. Very fine. Then what is v vector? What is the velocity? What is the formula for that? It is the derivative of the position vector with respect to time, dr by dt. This is the velocity, right? So this is equal to, okay, what is r vector? I'm writing here xi vector plus yj vector plus zk vector, right? This is position vector. It is given that x vector is equal to 4 cos t, right? Here it is given that x is 4 cos t, y is 4 sin t, z is 6t. So writing here for x 4 cos of t I vector plus for y 4 sin of t j vector plus z is given to be 6t k vector. Let's differentiate this with respect to time t. Derivating the first term, what we get? Minus 4 sin of t I vector plus derivating the second term, we get 4 cos of t j vector. Derivating the third term, we get 6 k vector. Right? So this is the velocity of the particle. So for time t equal to 0, what is the velocity? It is sine 0. Just put t equal to 0 over here. What is sine 0? It is 0. So first component is 0. Cos 0 is 1. So it is 4j. And then plus 6k. So this is the required velocity of the particle at time t equal to 0. And at time t equal to pi by 2, they have also asked to find the velocity at t equal to pi by 2. So for this, what is the velocity? Sin pi by 2 is 1, so it is minus 4i vector. Cos pi by 2 0, then plus 6k vector. So we have found the velocity at the given times. Now let's find the acceleration. What is the formula for the acceleration? It is derivative of the velocity with respect to time, right? So it is d by dt of, we need to write the value for v vector, that is this one, minus 4 sin t I plus 4 cos t j plus 6k. Let's derivate this with respect to the time. So it is minus 4 cos, so it is minus 4 cos of t I vector minus 4 sin of t j vector. That's it. The derivative for 6 is 0. And now we need to find the acceleration of the particle at time t equal to 0. What is that? At time t equal to 0, just put t equal to 0 in this acceleration. We have cos 0 is 1. So it is minus 4i vector. And sin 0 is 0. That's it. It is 4i vector. And at t equal to pi by 2, what is that? The acceleration is Just put equal to pi by 2 over here. Cos pi by 2 is 0, so it is 0, and sin pi by 2 is 1, so it is minus 4j vector. So these are the accelerations at these two times. And now we need to find the magnitude of velocity and acceleration, the second part. In the second part, we need to find the magnitude of velocity and acceleration at any time t. So the magnitude of velocity, we have found our v vector to be equal to minus 4 sine of t I vector plus 4 cos t j vector plus 6k vector. It is the square root of the sum of the square of the components of the velocity, plus the square of the second component plus the square of the third component, square root of, okay, so this is 16 sine square t plus this is 16 cos square t, and this is 36. If I take 16 common from these two terms, we have sine square t plus cos square t, that is equal to 1, right? So it is the square root of 16 plus 36, that is the square root of 52, or it is equal to 2 square root of 13. So this is the magnitude of the velocity at any time t. And now we need to find the magnitude of the acceleration. At any time t, the acceleration is, we have found this to be minus 4 cos of t I vector minus 4 sine of t j vector, right? And now finding the magnitude of this acceleration, so that is equal to the square root of the sum of the squares of its component, 4 cos t whole square plus 4 sine t whole square of its components. So this is equal to the square root of, okay, so this is 16 cos square t plus 16 sine square t. So when taking 16 outside, we have cos square t plus sine square t, that is 1. So square root of 16 is 4. So the required magnitude is 4 for this acceleration. So here ends up the solution. Okay, thank you.